Every single day, millions of us step into an elevator without giving it a second thought. But what is it that makes that ride so smooth, so quiet, and so incredibly safe? Well, it's not magic. It's actually a masterpiece of hidden engineering. So today, let's dive deep into one of the most critical components of that system, the elevator guide rail.
The experts over at Novin Pooya Lift have this amazing way of describing it. They call the guide rail the hidden spine of an elevator. And honestly, that's the perfect metaphor. It's this silent, incredibly strong, and absolutely essential component that does all its work completely behind the scenes, literally forming the backbone of your ride.
All right, so here's what we're going to break down. First, we'll look at its crucial role. Then we'll get into how it's made with insane precision. We'll figure out how engineers choose the right one for the job and why its support system is so important. We'll even check out designs for extreme weather, and finally, we'll reveal the real secret to a perfectly smooth ride. So let's start with the basics. What exactly is this unseen backbone? I mean, if you could peek into an elevator shaft, you might just see a simple steel beam running up the wall. But trust me, its job is anything but simple. Okay, so here's the official breakdown. It's a T-shaped steel profile, and its main purpose is to create a perfectly straight, super rigid path for both the elevator car and its counterweight. And that T-shape? That's no accident. It's specifically engineered for maximum strength and stability. But this thing does way more than just guide the elevator up and down. It has 4 absolutely critical functions. Number 1 is guidance, sure. But number 2 is emergency support. If something goes wrong, the safety gear, sometimes called a parachute, literally grabs onto these rails to bring the car to a halt. It also fights off sideways forces from wind or even earthquakes, and it acts as a stable base to mount other important gear. So yeah, this is so much more than just a simple track. Now, not all guide rails are created equal, not even close. The way they're manufactured has a massive impact on how an elevator performs, especially when it comes to speed and how smooth the ride feels. And that brings us to the 2 main manufacturing methods, cold drawing versus machining. You can kind of think of it as the difference between good precision and absolutely perfect precision. Cold-drawn rails are fantastic for the kinds of elevators most of us ride every day, in apartment buildings or small offices. But when you're talking about a skyscraper, for those super fast elevators, you need the flawless, pristine surface you can only get from machined rail. Let's dig into the details here, because this is where it gets interesting. Both start out as hot-rolled steel, but then cold drawing pulls that steel through a die to shape it. It's accurate to about 1/10 of a millimeter, super cost-effective and perfect for most jobs. Machining, on the other hand, is a whole different ballgame. They use tools to mill the surfaces down to perfection, getting accuracies down to hundredths of a millimeter. And that tiny difference is why machined rails are the only option for high-speed elevators, where even the tiniest bump would feel like a huge jolt. Okay, so we know how they're made. But how do engineers actually pick the right rail for a specific building? Well, it usually comes down to a pretty straightforward naming system and really understanding what the building needs. Exactly that question, right? How do you pick the right one? Well, the answer really depends on 3 big things: how tall the building is, how fast the elevator needs to go, and how much weight it has to carry. So let's say we're talking about a typical 4 or 5-story apartment building. The speed is pretty standard, the capacity is normal. The smart, reliable, and cost-effective choice is a cold-drawn rail. Models like a T70 or a T75 are the workhorses of the industry. That number, by the way, usually just refers to the width of the rail's guiding face in millimeters. Simple as that. But the moment you start building a skyscraper, the entire rulebook changes. For those elevators that have to whisk people up 80 floors in seconds, you absolutely need the precision of a machined rail. You'll see model numbers like T89A, and that A is key. It usually tells you it's a machined, higher tolerance rail, built for a ride that feels incredibly smooth, even when you're moving at unbelievable speeds. And then you've got your special cases. Picture a hospital elevator that needs to carry heavy medical beds and equipment, or maybe a massive freight elevator in an industrial warehouse. For these, speed isn't the main thing. It's all about pure, brute strength. That's when you bring in the biggest, most robust machined rails, like a T127A. They have a wider, thicker profile that just won't bend under all that weight. So we've gone out and picked the absolute perfect rail for our project. We're all set, right? Well, not quite. because the best guide rail in the entire world is completely useless if it isn't installed with absolute pinpoint precision. And that's where the support system, the brackets, and the alignment comes into play. This is really where the whole system comes together. A high-quality rail is only one piece of the puzzle. You need brackets that anchor it to the building like they're part of the structure itself. And then you need an alignment process that guarantees a perfectly vertical path from the very bottom to the very top. Even the tiniest mistake here is going to translate directly into vibrations, noise, and a bad ride. And you have to wonder, right? How on earth do they do that? We're talking about achieving millimeter-perfect straightness over the height of a massive skyscraper, usually in a dark, unfinished, and frankly, kind of creepy elevator shaft. How is that even possible? The answer? Lasers. Seriously. It's pure high-tech. Technicians use these incredibly precise lasers to shoot a perfect vertical line straight up the entire shaft. Then, they mount these adjustable brackets and begin this slow, meticulous process of fine-tuning each one, just nudging the rail until it lines up perfectly with that laser beam. It takes a ton of patience, but the result is a path that's true to within fractions of a millimeter. Of course, not all elevator shafts are nice and cozy inside a building. What happens when you put an elevator on the outside of a building exposed to the elements, or in a super humid place by the coast, or somewhere with crazy temperature swings? Well, the guide rail system has to be engineered for all of that too. And engineers have some really clever solutions. For that humidity problem, they'll hot dip galvanize the rails, coating them in a protective layer of zinc to stop rust. For outdoor elevators where the steel expands and contracts with the heat, the brackets are designed with slotted holes to let the rail move just a tiny bit without buckling. And to fight against strong winds pushing on the car, that's simple. You just use heavier rails and place the support brackets closer together. Okay, so we've taken a pretty deep journey inside the elevator shaft. So after all that, what is the secret? What's the magic formula for that perfectly seamless, quiet ride we all want? Well, it turns out it's not just one thing. It's a very specific recipe. The quality of the rail itself is obviously the biggest ingredient, making up about 40% of the final result. But look at this. The precision of the insulation is almost just as important, at 35%. And the design of the bracket system makes up the final 25%. You absolutely need all three parts of that recipe to be perfect. And that, right there, is the biggest takeaway. That seemingly simple T-shaped beam of steel is so much more than it looks. It's this amazing combination of material science, incredibly precise manufacturing, and expert, painstaking installation. So, I'll leave you with this. The next time you step into an elevator and feel it glide effortlessly up to your floor, just take a second. Think about that silent, unseen hero working just behind the walls, that perfectly aligned steel backbone doing its job flawlessly to make sure your journey is smooth and, most importantly, safe.